Hi, I'm going to take you on a tour of NASA's EYES software. This is web-based free software. You can go to the homepage that I'm showing here, eyes.nasa.gov, and you can actually follow along. So you can try this on your phone, your desktop, laptop, what have you, tablet, and just you can do what I do. It's web-based, so all you need is internet connection and a browser. So eyes.nasa.gov is a visual way to show you what's going on in the universe and where NASA's missions are at and what kind of data they're taking. So when you go to the home page, you see right at the top, Solar System Interactive, Eyes on the Earth, Eyes on Exoplanets. I'll take you through each one of those. And we'll go ahead and land on Mars while we're at it. There's also older desktop versions that are like a video game you kind of download and install. But those require PCs or Macs only and no mobile phones or tablets. And finally, we do have a spacecraft AR app on mobile that's pretty fun. So if you go to the App Store, try this out, you can put the rover in your living room. But I'm going to show you the main products. So we also do Deep Space Network Now, which shows you who's phoning home this very second. So as you can see, Juno is phoning home to Madrid. Juno is a mission at Jupiter. Lucy just launched. It's an asteroid mission. Lunar Reconnaissance Orbiter is phoning home right now. It's at the moon. So lots of cool stuff. Voyager still actually talks to us. So right around the world, we have a station every 8 hours so that no matter where a spacecraft is in the universe, it can phone home somewhere. It has a direct line of sight to either Australia, Spain, or the United States. So you can watch it all the time right here on DSM Now. Pretty cool. All right, but let's go ahead and jump into the solar system. Just click on Solar System Interactive. It'll make a new window, and off you go. This is a live look at the solar system and a whole bunch of NASA missions at it. So let's go ahead and look around. You're free to go anywhere. You're in space. This is all to scale, 1 to 1 to 1. The trajectories are all correct. The spacecraft are from the CAD models, the engineering models, and their position is from the engineering data. So here's Earth. Lucy just launched, as you can see. This is an asteroid mission that recently launched. You can tell by where its trajectory is. Let's go ahead and go to Earth. In Eyes, when you see a label, you can kind of just click on it, and in you go. So here's Earth currently, real time, as I do this demonstration. You have a search panel down here. You have an HD button, which I'm going to go ahead and click so we get really nice textures on Earth. And you can light it up, floodlight it if you want with this little icon. And let's go full screen to make it look really good. Okay, so as these new textures load in, let's just go pick a spacecraft to fly to. So this should be yesterday's actual Earth. So this is real global mosaic of Earth yesterday. And by the way, hit the W and S keys to zoom in and out, or you can just scroll with your mouse wheel. And if you want to scroll really fast, hit Shift W or Shift S. All right, let's go to the space station, ISS. This is an exciting mission. There's always some astronauts aboard here. Here it is, and ooh, look at that imagery. So this is real time. This is where it is right this second as I record this. What a view. Look at that. Again, these are real images from yesterday. So it always has the up-to-date global mosaic if you hit the HD button. So wow, so the space station is pretty majestic and it's pretty large. There's a compare size button here. So here's the space station, and we can compare it to other missions like Juno. That's too small. Most of them are going to be too small, even Voyager. So let's go to a school bus. So even the school bus is small compared to the space station. So what do we need? We need a stadium. Here's the Rose Bowl in Pasadena, California. Now we've got something that fits the space station's size. So this is comparison mode, and you can do this with everything in our Solar System Interactive. But back to the space station. We do have unnatural lighting on. So if I turn that off, ooh, it's dark. We're on the night side, so let's pull back, see where we are. So we're crossing Asia. So if I actually show you where it is, it's almost to the sunrise. It is actually pretty cool to see the sunrise. So I'll let you in on a little trick. If you click on the date 6 times, just click 6 times on the date and time, you can fast forward. So let's watch the sunrise on the space station. Make sure I've got it. So there it is. The sun's coming up shortly. Let's turn this off and slowly fast forward to see the sunrise. Oh, there it went. It's very fast. So let me go back. Oh, so it's beautiful. We actually have some cool kind of physics in here, so we can actually simulate the actual sunlight hitting and changing as it comes up. So there's the sun rising over the horizon. That is beautiful. So you can play like this all day. You can leave this on your monitor when you're gone. You can just cruise around with the space station all day. So let's watch that sunrise light things up. So if you're on the space station, you get 16 of these a day. Sunrises, sunsets, pretty cool. So yes, we have dynamic lighting. We try to do everything as realistically as possible. Okay, so let's go back out to the solar system. Let's go to our most populated planet besides Earth, and that would be Mars. We have a lot of missions at Mars. See right here, we've got the InSight lander and the MSL, the Curiosity rover, which landed in this crater here called Gale. So you can actually see its landing site and how far it's traveled in the last 9 years. Pretty cool. And then if we look around, we have a lot of orbiters. There's Mars Reconnaissance Orbiter, which has been there since 2006. So here it is in real time with those cool HD images of Mars. So it's just cruising over the North Pole. It's got a fantastic telescope here. It's very large. It can take images of the ground at 1 foot per pixel. 1 foot per pixel. 20 centimeters per pixel. An amazing mission, still going strong, taking incredible pictures of Mars. Okay, let's go back to the Mars system. As you may have heard, we landed a new rover called Perseverance. This one on the other side of Mars. So let's go look at it landing. So if you click on this right here, we actually had an entry, descent, and landing simulation. So let's watch that. It's very exciting. So this was made in advance of landing based on how we intended it to land. And it actually did land pretty close to this. All the timing was pretty good. We weren't off that far. Here it is above Mars, ditching its solar panels. And on the left, we have kind of scrolly telling. So if you want to go to the next stage, you just scroll down. You can go stage by stage as it makes its way down and see how it works, which is pretty fun. And if you're impatient, you can speed up time here. 1 minute per second. Let's go back to real time. So now it's getting guidance. There's the landing site down there. We're above Mars. The rover is actually inside here under the heat shield. Our SUV-sized rover is underneath this heat shield. Pretty cool. Let's just go ahead and get closer to the ground. It's going to straighten up and fly right here. And then it's going to deploy the parachute. So there it is. There goes the parachute. The special secret coded message here. And we're off to the ground. And the next step is heat shield separation. So this is going to go right now. Boom, there it is. So there's the rover all tucked away inside there, including the helicopter. So our Mars helicopter is inside this. It's like pregnant with the Mars helicopter right here. So it's inside there, and they deployed it later. And it's still flying around Mars today. All right, let's get on down to the ground. This is very cool. Right now it's taking pictures of the ground to figure out where it is autonomously. So it can divert if it needs to. Found a solution, knows where it is, and boom, we dropped the rover. So now the rover is free flying above the surface of Mars by remote control. Nothing we can do on Earth. We've already sequenced it, programmed it, made it smart enough to land on its own, because with the light delay, there's nothing we can do. There's no time to change orders. The delay is like 12 minutes or something at this point. So pretty cool. It has its own rocket-powered descent engine. It's holding the rover under it. This is very dicey stuff when you consider how expensive and how long we've worked on this and how there's very fine instruments on it. one of the hardest things to do, is land on Mars. Here we go, rover separation. We lower the rover to the ground on cables. The rover puts its wheels down. Other orbiters, like Mars Reconnaissance, are taking pictures and monitoring and relaying data. And then the rover is gently dropped to the ground, the cables detach, and we have a roving geologist on Mars at our command with a drill, with a laser, with an RTG on the back for at least 14 years of power. Pretty cool. Okay, let's exit out of this and let's go to the next product. So I also showed you Eyes on Earth. So you just click on this banner and let's see some actual Earth data. So you open this up, you see our NASA fleet zipping around. These are all Earth science missions. Let's click on the date and go to real time. So this is where they are right now this very second. Look, we have 2 Landsats by each other. Landsat 9 just launched. Let's go have a look at Landsat 9. It's the new kid on the block, but it's the 9th mission in the Landsat series, which is crucially important that we have a continuous data record. We have pictures of the Earth, the entire Earth going back to 1972. So a continuous data record is very important to show what's been happening in various places on Earth over time. So let's go to Visible Earth. This will also be yesterday's global mosaic, actual pictures of the Earth from yesterday. Here's California. Actual cloud cover. And JPL NASA is right here. You can animate the data. You can go back in time. So let's click on this. It'll actually load up the last 7 data sets and play them. So one by one, you can watch the weather ticking by, which is pretty cool. You can actually just kind of forward and advance it yourself. The last 7 data sets. But we also have vital signs. So you can pick out things like surface temperature. So here's the surface temperature of Earth, and just click anywhere to see the temperature from the last 3 days. This is a 3-day average. And you can see the blue line, that's freezing. So anything inside the blue line is freezing. Anything outside is above freezing. So let's make sure Antarctica is still frozen. Very good. It gets really cold here. You can also change to Celsius if you like. You just hit the toggle units button here. So for most of the world, they prefer Celsius. And you can also animate this data as well. Or you can check out things like carbon dioxide or carbon monoxide. So let's look at carbon monoxide. And you can see recent fires. And current fires, there's quite a lot of fire going on in South Central Africa. This is parts per billion of carbon monoxide at 18,000 feet. So the wind will actually blow this stuff around. So let's animate this and see just how quickly it blows. So it goes around the Earth pretty quick. So carbon monoxide is something we've got to keep an eye on. This carbon monoxide can turn into carbon dioxide even though it isn't a primary driver of CO2. Okay, so you can also select other data sets like sea level, ozone, soil moisture. Here's soil moisture. We actually can measure how moist the soil is. So the Amazon River, obviously doing well. A little dry here in the American Southwest. And you can animate this data as well. You can also go to events. So by year and by type. So if you want to see nothing but fires, here you go. Air pollution blanketing India recently. Let's go look at that story. There's a nice picture of the current conditions in India. We can go to any other type of event. We can go to all events. We can go by year. So if you want to go back 5 years, there's tropical storms, dust, typhoons, etc. So you can kind of see what's going on and view it on the globe, as a matter of fact. So you can actually open up the globe with all these events and then click on them as you see fit. So that's the latest events. And the latest one will always be here right at the top. Okay, so that's Eyes on the Earth. It is embeddable. So if you want to put it on your own web page, you want to select even any vital sign and just show that, you can just go to this URL and do an iframe, and you can stick this on your website. Okay, so finally, I want to show you exoplanets. So we click on this. Let's go to Eyes on Exoplanets. and we can go to any exoplanet we've ever discovered. So just for context, let me pull out and get to the galaxy. So here's the galaxy. So that's pretty ultimate context right there. We're over here, and all this crazy stuff here, those are all exoplanet systems we found, including these that go to the center of the galaxy. Every single little light here is another planet we found around another sun. That's all exoplanets means. It just means planets that aren't in our solar system. They're out of our solar system. Let's just pick one at random. Just click it. So here's one. Ooh, looks like the planet is in the habitable zone where we think it could support life. That's always good. Let's click on the planet itself. This is a hypothetical texture on the planet. We just think it's kind of a gas planet, similar to Jupiter. So we put on an imagined image, but its system data, its period, its mass, its location are all accurate. There are some close to us at Earth, relatively speaking. So TRAPPIST is a very exciting system. It's only 41 light years away, but it has a whole bunch of exoplanets. Let's look at the system here. This was very exciting when it was found a few years ago. So TRAPPIST-E, for example, is in the habitable zone, so we think it could possibly support water and life. So it could look like this. We don't know. We don't know. We can only get a pixel or two of spectrum with our current telescopes, but the future telescopes will get more. So we'll get a feeling of what's in the atmosphere once we get some spectrum pixels. Okay, so that's exoplanets. You can get the current count every day, 4,569 planets. And every single one is represented here. Every single one. Just click on whichever one you like. This crazy pattern is from the Kepler Space Telescope. It actually stared into space for years in the same direction, and look how many planets it found. Found so many that you can see the lines between the light collectors here. It's actually the CCD. So you can see where there's no light collecting material. Pretty cool. Okay, and finally, I want to give you a cool heads up on a future product called Eyes on Asteroids. Eyes on Asteroids should be out by the time you see this. We have envisioned 27,000 near-Earth asteroids. So a near-Earth asteroid is one that gets uncomfortably close to Earth. Most of them are inside the orbit of Mars and Jupiter. So we fast forward, you can kind of see these things zipping around. So now we're in 2022. We're going 3 weeks per second right now. You can go back in time as well. Back it up, speed it up. And you can see certain well-known asteroids represented with labels. You can also see missions that are just launched, like Lucy and DART. So DART is pretty interesting. It's actually going to impact an asteroid. So let's go to DART. By the time you see us, DART should have launched. And it has a very exciting event. It's going to crash into a binary asteroid system like this. So on purpose, now we're not showing the crash, on purpose, next year we're going to crash into this smaller piece of the binary system called Dimorphos with our spacecraft. And we intend to deflect the asteroid, see if we can do it. It's a test. It's a test to see if we do it early enough and even move it by a couple centimeters, we can change the orbit of this system. This is a potentially hazardous asteroid itself. So we can actually find out if we can deflect an asteroid for real. So that is happening soon. It's very exciting, and that's that system. Let's go back to asteroids. You can learn about them. You can learn about what is a close approach with our scrolly telling. We have a really big close approach in 2029 with the Apophis asteroid. Seen here, April 2029, going right by the Earth. It's only about 37,000 kilometers away, which is kind of near some satellites, but it's not going to impact Earth, but it gets pretty close, way inside the moon's orbit, as you can see. That's how close it gets. So you can explore this with Eyes on Asteroids. You can go to famous asteroid missions like OSIRIS-REx. You can go to the Near Shoemaker mission. You can learn about it, and you can also check the next 5 closest approaches to Earth. And there's a little countdown. See where they're going to be. You can click through them. They're going to miss by a long way, but you can keep an eye on them with this app. Okay, that's all the time I have. I want to reiterate, go to NASA's Eyes at eyes.nasa.gov and have fun.